Okay, so now we are doing third problem of today's Codeforces contest 853. What is the problem change? Change is nothing but just a distinct spelling was wrong. Sorry. So yeah, 853 div2 third problem server and Toxel array. You haven't given t number of text number n and m, the length of the array and the number of operations, and then you haven't given array integers, n integers, right, array, and then there are some queries, m queries, and then each query contains a p and v, this position and the new value, and then you have to modify this array, and then you have to tell the sum of the values of the pairs of the array. This question is very interesting, so just try to think about this. Just try to think about this. You haven't given a array initially. Initially, one array is given to you. You are making some modification of this array. It's not a segment regression, first of all. Okay, so you are making some modifications of this array, and and the array changes into something else. We know that we modify this array changes to something else. You have to consider that array also, previous array also, and all such arrays which will be forming after the m operation. M such arrays will be forming, right? Now what you have to do, you have to take concatenation of these array with themselves. So m arrays are there. How many possible concatenations will be there? MC2, right? So MC2 concatenations will be there. Concatenate every other array with every other array possible, and then see what is the distinct element on this concatenated array, and do what? Do the uh sum of not sum of yeah just calculate count the distinct elements in all of this concatenated array, and then do sum of that, right? So first of all you have m arrays, right? hmm? M arrays you have. Each array will contain at max how many elements? N plus m. No? Oh yes. Hmm? Like in this case, at max it can contain n plus m elements. But that's not obviously true, but yeah. Hmm. Okay, so basically let's see what you have been given. Let's see from the test cases. Uh, am I able to explain the question? Do you get the question? What question is given to you? You have been given an array initially. You are changing some position of this array to some new value in these queries given to you, m queries given to you. So there will be m changes to the array will, you know, move forward one by one change. So yeah, there will be m changes in the line. How it is, you can see this like this. First array was 123, then you change this to 423, then you change this 423 to 453, right? It's not like this 123 is getting changed to 453, 423 is getting changed to this. So this is kind of chain is forming. Chain would be of how much length? Currently it's of 3 length. Why it's of 3 length? Because m was 2. M was 2. So if m length is let's say if m queries are given to you, the chain will be of length m plus 1. And now how many concatenations would be there? Like you can concatenate any two, so m plus 1 c2, that many concatenations. And how many elements can be in these concatenations? So at max, what I'm saying, at max, if 123 was given to you, and then at max this can be the thing now. uh let's say you change the first element, you change the second element, you change the third element. How many numbers you can change? You can just change m elements, m times you can change such elements. The total number would be in the array would be, initially there are n elements, m elements you are inserting, right, kind of. So total number of just valid elements would be n plus m at max at any point of time. Currently it is that. So n plus m. And then there's m plus 1 c2 kind of concatenation. So multiply this with your n plus m. Okay, don't multiply, just stick with it. The idea of the problem is clear. So now let's see from the example. Okay, you have three array of size 3. Then you have these two queries. Let's see what will happen. You have 1 to 3. It will change to something like 1 will change to 4, 2, 3. Then 2 will change to 5, 4, 5, 3. Now you concatenated it. It's already shown, so you can just see over here. So then you concatenated one with there are three possible concatenations possible because there are yeah, 3C2. 3C2 is also 3 elements. You have to choose any two of this and concatenate it with each other. So 3C2. So one will go with 0, 0 will go with 1, or you can say yeah, first array will go with second array, first array will go with third array, and then second and third array can go with themselves also. So this is the thing being shown over here. You count the number of distinct elements, then you plus it. So how to do this question? That is the thing how to do this. Whew. So let's think about this. Okay, so that's all about the problem. Now let's move towards the logic, right? So let's first copy paste the test cases and see. I think we have done that, right? Yeah, we have already seen that. So now these will form 3C2 possible cases, right? That is in front of you. 3C2 is also 3. So these are three concatenations possible. First mid is 4 distinct, 5 distinct, 4 distinct. So the sum is 13. So now how to get to this, the logic, you have to move with the logic. So let's see the logic. First observation. So first thing which you have to do is to, fix the elements. Okay, fix the elements. We will fix the initial array only. So let's take this case or this case. Only three cases are given to you. So first one is middle size. So yeah, we'll take this one. So first say key that okay, initially 1, 2, 3 is this. So how many times 1 will occur? I will say that like I'm not changing 1, I'm not changing 2, I'm not changing 3, and every time these only elements will occur. So in every array, so every array will look like this: 1, 2, 3, 1, 2, 3, and 1, 2, 3. And when you make a concatenation with 1, 2, 3 again, so the three elements will be there. And yeah, so every element will be occurring m plus 1 time because m is 2 in this case. So every element will be occurring 3 times. Like these are the three possible array, and this will be three concatenated array also, because why these are all three possible array, because I'm saying that I have not made any changes. So yeah, that's the thing. So when you concatenated this with this 1, 2, 3, 1, 2, 3, okay, now that in concatenation we are not taking the repeated element, we are just taking the distinct element. So 1, 2, 3, 1, 2, 3, again the concatenate, this part just gets yeah, distinct part is just 1, 2, 3. So that is the thing. The thing answer for this is the concatenated array. This is not the in process like chaining array. This is not the array present in the chain. This is the concatenated array, right? This is the these are the array present in chain. This is the concatenated array. So C1, I'll say concatenated array has three elements, and then this also has three elements, and this also has three distinct elements. So answer will gonna be 3 into m plus 1. And what I'm saying that every element is occurring three times. So one is occurring three times, two is occurring three times, three is occurring three times. I just want to know, like, because at the end I want to know like how many distinct elements are there in concatenated, like, yeah, how many distinct elements in C1, C2, C3, and then some of them. So I just want to know that like how many elements are just coming, right? Aren't we are looking for that only? Yes, indeed, we are looking for that only, and then the repetition of that element. So one three times, two three times, three times, because there are three arrays. So there are m plus one total arrays. So at max, a number can have repetition of m plus one or less than that. So now total elements can be n plus m. Yeah, these are the total number of elements that can be there, and the number of concatenations is not m plus one. The number of concatenation is m plus one c2. Let me remind you. So yeah, that is the thing. Now the thing is I would like to see that in the final concatenated m plus 1 c2 concatenated arrays. So let's keep it over here. These are the total number of can be there, and final this final mc2 kind of all these concatenated arrays, like how many arrays have this particular element. So there are only n plus m elements, right? Let's say there is x12 x of n plus m. I want to see what is the frequency, how many arrays contain this x1 plus how many array contains this x2. plus how many array contains this x3, because all those array which contain the x1 will contribute 1 to that array. Okay, this is c1 to c2 up till c of the final bigger number is m plus 1 c2, total number of arrays present, right? Now I'm saying how many number contains x1. So x1, let's say this contains x1, this contains x1, and let's say some of the elements contain, let's say there are total n arrays which contains x1. So n arrays contain x1. So how much my x1 is contributing? X1 is contributing n, because that is a frequency how many times x1 is occurring. So this is not x1, this is frequency of x1 basically, because in each array it will be present at most one only. So at most one only, and it is counted as just one only in each array. So I just want to see how many number of arrays it is there. So that is the frequency, and then I will just do some of that. If you want to see like in this thing, uh you see that there are three arrays. I will ask how many array contains one. They'll see three. So I'll say plus so I want to like just copy paste this and to show you that one way is obviously this, that if you have these array, you can just for sure what's happening. I just pasted like this. Okay, I think I can try this again, and I should paste as plain text. I think I don't know what is this concat, but I just want to show you these parts. So let me just paste it like that. First part is this array, yeah. Second part is this I want. The next part is this. This contains four elements only, right? Now what I'm saying, instead of doing this 5 plus 4 plus 4, you just see how many times 1 is occurring, how many times 2 is occurring, how many times 3 is occurring, because there are occurring just one in just one array. So you can just say how many arrays the 1 is occurring, how many arrays 2 is occurring, how many arrays 3, 4, 5 are occurring, right? Array, no man, you have to cancel out this 2, 3 repeated, 3 is repeated, and 2, 3 is repeated, 4 is repeated, 5 was there, right? 4235 was there. 4235. Now just check how many times one is occurring. Okay. Do this formula over here. Now just copy paste this for just a second. So I'm saying one is occurring two times. Okay. Now how many times two is occurring? Two is occurring in all three arrays. So three, frequency of two is three. Then house frequency of three, three is three. Four is three. Five is just two. And would come out as, you can count, I'm not counting, 4 plus 4 plus 6. 4 plus 4 is 8 plus 6 is 14. Answer is 13. How it is possible? 4 plus 4 plus 6. 6 plus, yeah, 14. But I think there's issue, like 1 is occurring how many times? 1 1. Okay, 2 is occurring how many times? 3 times. 3 is occurring 3 times. 4 is occurring 3 times. So why 4 times? How it is possible? Yeah, it's not possible. So that's why the answer is 13. Okay, but yeah, that's the thing. Now what you have to do, you have to count the frequency of elements. You have to count how many arrays this particular element is present. Now how I will do that? First I said that I will say that okay, I'm not doing any operation. So one is present in three arrays, two is present in three arrays, and three is present in three arrays. So everyone has frequency of m plus 1, m plus 1, m plus 1, and so on. Okay, but this is not true. Yeah, this I'm just assuming this, and we will making it false, like by not making it false, but we will update this whenever the next new element comes at that position. So let's say some element comes at the position, let's say index, I have to also mark indexing. This is index 0, this is index 1, or you can say position 0, position 1, or position 2. So I have to say that, yeah, that's this. And now I have to say that element is coming on the first, new element is coming on the first index. So this element is not occurring m plus 1 times. So m is not 2 is not occurring in all arrays. Why? because 2 is getting replaced by someone, and now I'm saying that someone will be taking over after this point. So currently, let's say uh, there are m operations or m queries that you are running. So I said that 2 will be there at the first place for all the queries, but it's not true. At some ith query, someone will take over. Let's say x take over at the first index, so x will come or m minus I times. Agree or not? M minus I time. Why? Because yeah, because I times has already occurred previously, and m minus I times is remaining in the future. So that is so I will decrease this frequency by m minus I and increase the frequency of this by m minus I. But now next say कि some jth element occur, and some jth query, some yth element occur and say कि I am present on the first index. So I will say that okay, do m, it's not m minus I you are giving complete to this x element, you are minusing m minus j, because that times now that one will be coming up. So now that one is like y will be coming up m minus j times. So yeah, now it's time to code. Okay, now it's time to code. So just initialize this and then minus it with this point whenever you see that okay, now someone is taking over at this position, so now he will continue from this side. So in this example, if I can show you, so initially one was at the first index, right? Why one is not in this array? Because 4 took over. When did 4 took over? First 4 took over at the so first I said that m is occurring three times, 1 is occurring three times, 2 is occurring three times, and 3 is occurring three times. First I said this because yeah. Now I said that first operation. Let's see which is coming. 4 is coming. So I will say that 1, reduce your frequency by 2 units. Why 2 units? Because m minus 0 is just yeah. Reduce your frequency by 2 units. You will just be coming once. Just becoming once. Okay, why once? You should just decrease it by 1. Sorry. M plus 1. M plus 1 you have to give it because, yeah, yeah. M is 2. You have to decrease its frequency with M minus I. I think you should decrease its frequency by M minus, not I, but M minus. Let's see if I decrease its frequency, because then frequency just becomes 1. That's not what I want. I want this frequency to be 2, and then I'll make 4 frequency to be equal to 2 m plus I, not m plus I, m minus I, which is 2. Yeah, that's fine. And then I will be saying that okay, next 2 5 is coming at the position of 2, so reduce the frequency of 2 by m minus 1, which is 1. Yeah, so now the frequency of 2 becomes 2, but it's 3. We will see this why it's 3. It's like that for the first second 2 is there, right? Because initially 2 is there, right? No doubt in that. But the next second like yeah, you can say the second 4 will come over, so 4 is getting taking its place, and this 4 is just remaining throughout. So 1 is coming, not m plus 1 arrays. 1 is coming in just, yeah, I'm just talking about these array. 1 is coming in just one of these array. 4 is coming in two of these array. 2 is coming in two of these array, right? 2 is coming in two of these array. 3 is coming in all of these three arrays, right? Now 4 is coming in two times in these arrays, right? In these array 4 is coming two times, 5 is coming just one times, and there is no one other than this. So now how I'll be calculating my answer from this? Now I need to concatenate with this with themselves, right? That is the next part what we have to do after having this. Okay, 1 is occurring one time, 2 is occurring two times, 3 is occurring three times, 4 is occurring two times, 5 is occurring one time. How to concatenate this? For concatenating, I will be saying that okay, for r is equal to 0 initially, you will be saying that 1 can come with all the other elements except 1, because taking 1 with 1 is not a good thing, right? Let's say this is the array which have first position pair 1. This is another array which have first position pair 1. When these two concatenate, 1 is coming just one time. So take this just once. So count the total number of such arrays which have just 1 in the first place, and then combining C1 with C2 is equal to combining C2 with C1. So count in C2, right? Just choose any two array. Let's say there are some arrays, let's say three arrays which are having 1. I'll be just saying count 3 C2, so that you combine every of these possible array, but just C1 C2 C2 C1 and then that is this good or not? Is this good or not? Yeah, that's fine. That's fine because you have to do that. You have to do NC2, and then it will be just counting just once. Okay, yeah, these array are just coming in the concatenated array once, which like currently if you see like 1 1 1, if that was the case, and then the 1 will come three times. Okay, even if 1 is present, like this is the scenario which is forming, but currently 1 is present just once in one of the array, and then in the first place there is another thing which is 4 two times. So you'll do 1 C2 which is giving you 0, so 1 is not combining with itself, but 1 is combining with 4. 1 and 4 can come together. No, no, no. Like when you combine something, yeah, 1 and 4 can come together, because when you combine something like having 1 on the first place, this is C1, this is concatenated array 1 which is having 1 of this first place, and this concatenated 2 and this concatenated 3 which is having 4 at the first place, right? So then you will be saying that when you concatenate this one with all the other arrays who have something number else than 1 at the first place, how will you know that all the arrays which have something other than 1? So I know that how many arrays have 1, that is stored in frequency of 1. 1 minus not minus into, I want to know all the other arrays which have like value other than 1. So that is equal to m plus 1, because the total number are m plus 1, and minus f of 1. Those are the arrays which are having on the first place anything other than else than 1, right? So that will be forming up the pair, good pair with 1, and I'll be doing this. Otherwise 1 C2 for all these ones, if there were so many ones, okay, not 1 C2, but yeah, the frequency of 1 C2, f of 1 C2, for all those elements, like say for these three, ones will be counted as just 3 C2, and now it will be counted as 1 will be counted with these frequency 3 into 2. Why 3 into 2? Because this one can form anyone, go with any of these two, this one can go with any of these two, this one can go with any of these two, also like this one can go with any of these two, and this one can also go with any of these two. But how to count that? Will you do f of 1 into f of 1? No, that would be very that would not be very good. F of 1 into f of 1, why it would not be very good? Like f of 1 into f of 4 is good, 3 into 2 is good, but because these are different things. But f of 1 into f of 1 is not good. F of 1 into f of 1 minus, because you want to choose two of them. It's not like you cannot, if this is 1 2 3, you can only do like 1 and 2, 2 and 3, and 1 and 3. Only these three things are possible. 1 and 1 is not possible, what I'm saying, right? Are you getting it? Are you getting 1 and 1 is not possible? Why 1 and 1 is not possible? Why 2 and 2 is not possible? And why 3 and 3 is not possible? And also why 3 comma 1 is not possible? Why 3 comma 2 is not possible? Because 2 comma 3 and 3 comma 2 will be same. In this case 3 comma 2 and 2 comma 3 will not be same. If this is 1 and then 4 coming up, and then 4 and 1 coming up, they still add up. But the basic thing is, like, when these two combine, when this 1 1 wala will combine 1 and 1, they are just giving, how much they are giving? They are just giving 1 1. Okay, because 1 1 is getting eliminated. Similarly, when C2 and C3 combine, they're just giving 1 1. So that's why this frequency of 1 is just 3 in the final also. But in this case, when 1 and 4 combine, we are getting two elements at the same time. Two elements at the same time. And similarly, one can combine with any other. Let's say 5 was there, so one can combine with 5 also if 5 is occurring at the first place some number of times. So those many frequency will be getting combined. Okay, so this is all about the logic. This is the basic thing which you have to do for every number. For every number, you know, you have to count how many times this number is coming at this position, and how many times this number is other than this number is coming, yeah, at this position. So now let's code it up. First we'll start with this thing and give m+1 to everyone. This is Victor.
सोजा पे टाइम से बोलना मुगल गार्डन जाना तो चलेंगे इसके साथ
Victor int v size n
ऐसे करी
n comma q number of queries I'm taking, right? Or you can just say m because m and q are same in this case. And then you should have something like frequency array which will store frequency of all the other elements. So fr or f just m plus m total number of elements can be there. Initially the frequency of everyone, no, not everyone, is 0, but frequency of I and v, I'm saying that frequency of I is equal to m+1. I'm saying these numbers are just coming every time. So now we'll go for, yeah, 0 m queries basically. And enter, I will say ask about yeah, at which id you want to change and which new value you want to place. Id and a new value that you want to place, and then you want to change your previous value to your new value. How will you change that? Obviously you want to make some changes into f also. So f of previous value. So what is previous value? Previous value is something which is currently present at this id. It can be different at different number of times, because one thing is going to change, like after this id is going to be having new value. Like before this you have to do calculations, right? like like what I said, like for currently one is occurring, right? You just said that where you said one is occurring, that's this, and whenever the 4 comes, like when this query comes, give 1 to 4, give, yeah, first index पे make it 4. So you'll do array like this for 4 comma 2 comma 3. You'll put this on this index and you'll say that my turn of 1 is over, and m+1 minus me m minus I, that I said we will do m minus I with the ith element, and we will do 4 के लिए we will do addition. I'll say frequency of 4 plus equal to, not plus equal to, or yeah, equal to, yeah, no, plus equal to, it can come multiple times also. So when again m1 comes, so yeah, we can just plus equal to, so plus equal to m minus I, you know, because currently I'm standing on I and total there are m, so in future there are just m minus I um operations left, or number of concatenated arrays left, with which it will be combining, or like, yeah, 4 will be coming in these normal arrays, not concatenated but chaining array. These are all the chaining arrays, so 4 will be coming on after this. I'm saying like, but it's not like 4 will always be coming on after this. We will then, let's say 4 5 will come, so I'm saying okay, 5 is coming on the first place. So over the 4, how you will over the 4, you will say okay 4, uh, I thought you would be coming like all m minus I time, but you are not. You are not coming how many times? Like reduce yourself, like set another breaking point and then say ki, okay, now after this is the area of 5, like after this 5 will be coming up. So how many times 5? M minus j. Let's say in the jth operation I comes, so m minus j, just to do m minus j, because these will be going to f of 5 plus equal to m minus j, depending on whatever the j value is at. So first I want to do that. So but what is 4? 4 is the current element present at that current index, like where you are doing operation 1 comma 5, what is present on the first index? Currently 4 is present, so reduce 4 by this. And like why you reduce 1 by the 4? Obviously addition to those 4. Or why you reduce 1 by minus 1? minus equal to m minus I because 1 was initially present at that. How will you find out? F of whatever is initially present, that initially is basically I'm changing my v vector only. I'm not saying okay, so f of id we cannot do, we can do v of id only. F of v of id, or you can just make it more clear by saying int previous value at this position is equal to v of id, which was previous value at this position. And I will be saying frequency of previous value. I thought you would be coming all over, but you're not coming all over. So PR value should be minus equal to m minus I. This is very important. F of new value is plus equal to m minus I. Now I'm saying key, okay, I'm thinking that you will be coming all over, and whenever the new element will come, I'll reduce its frequency and increase that frequency, and that's will how it will go on. These three, four things you have to do, like yeah, and that's about it. It will form your complete F array. Fine. And you have all the elements, how many times they are occurring. Now you just have to see when they concatenate with each other, or what will be the value of your result. So I'm saying like for auto I n f, yeah, should we do that? Actually no, because we should go, because we are not using map, something like this. But yeah, if you would having map, then auto would be helpful. But yeah, C plus, sorry, NCP we use for vector more than map. So, and over here we can just take help of map, because your AI has a limitation. It can be just in n plus m. Yeah. So now I'll be saying what is my frequency of this I current frequency is equal to v of I, not v of I, f of I, frequency of I. Yeah. Now you have to say how many times it will get concatenated with others. Obviously, we are just seeing this concatenation with the element present at the same index kind of thing. Like not same index, but yeah, every element will be just once in the array. So let's say one is present in how many arrays one is present. Do I have that? Yes, I exactly have that. How many arrays one is present, that is stored in my f value. Now, when those two elements will combine, what will they give me? So there are, let's say, three arrays, chaining arrays. These are three chaining arrays, or not. It can be continuous, cannot be continuous. Anywhere there are just three arrays which have one, 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 and one can only be once in these array also. And now, if I concatenate this, I will have three C2, because these three I can take any two of them and concatenate them, and then I'll have just one one. So by combination, combining, I'll have one one. It's not like when I have 1 4 and 5. It's not like that. 1 c, or like let's say 1 4 4 or 1 1 4 4. When I'm seeing 1 and 4, how I'm seeing this, I'm not seeing this 1 and 4 as like this. So if there are all the other array, all the other elements, right, its frequency is this. Total frequency can be m minus m plus 1, and yeah, total frequency of any element can be m plus 1. I'm saying this is the first index of all the arrays, right? Yeah, like 1 is present in just one index only, but it can come on the other index also. But the thing is, one can combine with one, and then give us just like this frequency C2. So R plus equal to, I can just directly say that NC2 of this current frequency, and NC2 function will just return that, and then plus NC2 is very simple function, right? If you have int n, it will return you n into n minus 1 by 2. You could have directly done this over there itself, like we do in CP, but yeah, still looks good. So now the thing is that This is the frequency I have, current frequency of the current element. I'm gonna say its total frequency minus current frequency are the frequency of what? Basically, this is many. These are the arrays, right? There are some arrays. Total the arrays are total arrays. This is not total. This is total arrays. Yeah, m plus one. So in some of the arrays, one in this array one is present. In this array one is also present. In this array one is also present. But then there are some arrays in which four is present. Yeah, some other element is present. There are many such elements, right? What I will say, just count how many arrays one is present, and then when it concatenate with each other, so these two will give one, these two will give one, and this two will give one. It's not like again this and this will give one. No, it's not like that. But in this case, what has happened with 1 and 4 kind of thing, like the current frequency, total minus current frequency, like it's not 4, it's not 4. It can be anything. So these are the arrays, some arrays which does not contain 1. Some arrays which does not contain 1. Yeah, one can also come with this array, right or not? One come in this array? When I concatenate this is C1, right? Say this is C1. We were going in the wrong direction with 4 and 4. These are some arrays C1 and C2 and then C3 which does not have 1. So the arrays which does not have 1, one can directly go into these arrays, right? Directly go into these array, and then we can just count the frequency of total number of ones and total number of arrays which don't have ones. So total number of arrays which don't have ones, when one comes to into this, one contributes one. So C2, C3, and so on. So C4 and so on, Cn. So these are some arrays which does not have one. So when this one comes in these all array, it will give us one. It will give how much total? Total number of arrays which does not have one is 1, m plus 1 minus frequency of 1. These are the total arrays which does not have one. So this is this one comes into these many arrays, so this will do plus this, and then this one will also come into these many arrays, so we'll do again plus of this. So again plus of this, again plus of this, again plus of this. So for this one, this will come into these many arrays, m plus 1 minus frequency of one array, this will give you a plus 1. So that's why we are taking multiplication over here, because every time it is giving me the same value, because any of these ones, any of these f of 1 ones, let's say x1 ones, can go in how many arrays we already know where one is not present. There it can go, because we will have then plus 1 for that. One will come out as a distinct element. But when this one will go into these one of these arrays, that is also the same thing. Now I'm just choosing one of these elements, let's say x of 1. I'm choosing for everyone. So for first one, I'm choosing x1s, and then for the second one, am I choosing all x1s? Am I choosing all x1s? X1 is the frequency having, this is the second one. I'm not choosing all x1, because for first one I did, let's say I choose one which like this was, let's say uh, yeah, first was my CI, second was my CJ. It also has one. It has what is this x1? These are the total number of frequency of one. These are the total number of arrays having one. So we call it f1 because it's stored as f1. And I will do f1 minus 1. Why I'll do f1 minus 1? Because I'll not like, if I do 1 comma 2, I'll not count 2 comma 1 as again. Because why? Because yeah, because there's no point of counting them same, because there's no difference between 1 comma 2 and 2 comma 1. But why there is a difference in this? When you count this one with this, and when you count one with that this, because there can be some of the elements, let's say AB, and there can be some of the elements, let's say CD. Yeah, A and B, C, D are obviously different, and there is some array which does not have one, X, Y, Z. So when you combine this array, middle part of array, let's say this array X, Y, Z with first one, it becomes 1 C D X Y Z, which is different from this array when it combines with A B X Y Z. but that's why they are counted as 2 and all other because yeah. But why they are not same, or why they are same like 1 2 1 2 1? Because 1 and also contain 1 CD, all the elements that this contains, and 2 contains, and A and B also we are taking kind of union, and 2 all 1 and also contain the same thing, yeah, because that is the thing, that is the same thing. In this we are never taking in this scenario where we are not taking same pair of elements like 1 to 2 1, we are not doing that. I'm taking 1 with 3 also, 1 with 4 also, 1 with 5 also, and similarly I'm taking 1 with 2 with 3 also, uh, and 2 with 4 also, and 2 with 5 also. I think I'm over explaining this, but yeah, that's about it. So that's why this is multiplication, and that's why this is NC2, because one can combine with each other in just like 1 2 and 2 1 are not different. And over here the scenario is very different. One is going with 3 4 5, two is going with 3 4 5, because the second array does not have any elements which are equal to the first. No, don't go there, but yeah, this is the thing. Like one is going with 3 4 5, two can also go with 3 4 5, but this 3 4 5 does cannot be equal to someone which have one already, right? That is the thing. So that's why all those elements which have one will not be any common with this 3 4 5, because these 3 4 5 are obviously specially chosen which do not have one. Okay, so that's about it. I think over explanation, but yeah, that's about it. So NC2 plus this current frequency into all those which does not have this element, because then also I'll get one plus one for that. I will run this. I think that should be fine. Return your R final. Just I don't think we have to take mod, but yeah, long is fine. Long is fine. That's also long you can do. The thing is, also you can pass this as long. Mod we don't have to take, right? Let's test this. Frequency, very simple question in terms of 44 minutes, 42 minutes. TOT was not defined, total arrays, but yeah, whatever. We can just say m plus 1 also, but yeah. This is obviously not n plus m, this is n plus m. Plus 1 you have to do. Uh, v of I in v. Okay, now there is a thing that ID. There is a problem with this. They consider one indexing, we consider zero indexing. So ID minus minus. And then now, okay, still, let's see. N plus m equal to आएगा. Zero की वैसे need नहीं है, I guess. 131705 looks good. Zero की need नहीं है, but होने से भी it's doesn't make any difference. But yeah, let's check this. What is the rating of this problem? I want to know. And so yeah, the basic crux of the problem was very simple. Um, I think implementation was very simple, but logic was slightly unique in its own way. But yeah, it's like you have to initialize this with all the same elements and consider the frequency of everyone as m plus one. And then whenever new elements comes in, you say that okay, this frequency is now breaking, so you just decrease this frequency by m minus I, and then increase the frequency of the new element by m minus I by saying that okay, now after this point, the chain after this point in the chain, this new val will be going on forever. But then whenever when again the change comes, so you end that chain of that value and you start another chain. So this ending the chain, starting the another chain with the new value, and then obviously changing the v of id also to obviously change your previous value every time. And then after having those chains and then seeing which element is occurring how many time in each chain. Obviously every chain would have unique elements, but a particular element is occurring in how many arrays of that chain. So that is your f frequency. So now two arrays of that chain can combine. If both arrays like, now I'm not seeing in terms of array, I'm seeing in terms of value. If those array have so for this value, how many elements contain, how many arrays of this chain contain this value. Now I'll do C2 NC2 for that, because now these two, one and two and two one combine in NC2 ways. Yeah, unique ways. And then it can combine with all these elements, all these arrays which have this value can combine with all those arrays which does not have this value, and will give you plus one for that. So current frequency into total array minus current frequency. Let's see. Okay, wrong answer on 4. I think there is some long issue or what. So integer overflow, long you have to take everywhere. I think current frequency maybe. It should not be that, but what is the way to prevent this? Logic is fine, just so that was all about it. If you again see logic, so that is the thing. Just have your all the chains in this form, but you are only considering a particular value and frequency of this value and how many arrays this value is occurring. So you start with the first array and you assume that all the elements will have frequency m plus 1, and then you break that chain and you start new chain, so accepted. So this is the thing of breaking that yeah, this is how you calculate your frequency array, and then you will calculate your final answer using the frequency array of frequency array determines that this particular elements occur in how many arrays of that chain, and the total number of unique elements can be m plus 1, n plus m plus 1. So that's very less. So yeah, it gets passed in time complexity. That's about it. Bye.